KV10.5, in which we look at routes. So here's the next refinement of our app, and it's very similar to what we had before, only we've introduced an additional class, the route. In this way, a route has a set of waypoints. When we ask a route to draw itself, it iterates over its own set of waypoints, instructing each of those in turn to draw itself. So here we can see, and here's the route class, and you can see that we've moved the declaration of the array of waypoints out of the main app and into the route class. Now, importantly, this restructuring allows us to separate out all of the code to create a route and get it out of setup and into the new route class. So here's the code for the new class, and it has its own set of waypoint objects. Now when we create a route, we specify the file name in the constructor, and this is passed in, and then the constructor does the reading and setting up just as before, only now it's embedded inside the route object. So when we instruct a route object to draw itself, so this is the draw method for a route, it simply iterates over its own internal set of waypoints and instructs each of those waypoints in turn to draw itself. So this in turn makes the main app very much more elegant and sparse. In setup, instead of having all of the details of reading in the file, we now just create a new route from the specified file. And in draw, we simply instruct the new route to draw itself. So we've hidden an awful lot of complexity away inside two classes. So fundamentally, all that matters for the main app is the idea of a route that can be created and then drawn. And that's all we see in the main app. The detail of how a route actually works is separated out into the route class, and the details of how an individual waypoint works is separated out into the waypoint class. So by structuring things like this, we only see what we need at every level of detail, and achieving this sort of elegance is a fundamental skill in being a good developer, and it's the sort of skill that you only develop through practice and from looking at other people's examples, like this one. However, the application as it stands only prints out the waypoints and not the route. So how might we modify the route class to achieve this? So we assume that we can draw the route with solid lines and not the dots that Google Maps uses. Have a think. What's the basic algorithm for drawing a route? How would we modify the draw code in route to achieve this? Well, we basically need to skip through the list of waypoints, looking one ahead and drawing a line from the current waypoint to the next one in the list. Now, you'll note that we need to stop one waypoint short of the end, because if we try to access the non-existent waypoint after the last one, the next one after the last one, then we'll run over the end of the array. So we draw the line first and then the waypoint, so that the waypoints appear on top of the lines and it's much more tidy. So the basic algorithm is very simple. For each waypoint, if the current waypoint that we're on is not the last one, then we look ahead, draw a line from the current waypoint that we're currently standing on to the next waypoint, and then draw the current waypoint. So when we're on the last waypoint, it will simply draw the current waypoint. If we're on any other waypoint other than the last one, it will look ahead, draw a line from the current waypoint to the next waypoint, and then still draw the current waypoint. So here's the new code for the route drawing method. So we skip over the list of waypoints, just as before, and we miss out the last one, essentially, with this if statement. So basically for every waypoint other than the last one, Okay, we set the stroke to blue, and then we draw a line from the current waypoint XY to the next waypoint XY. So we can access the next waypoint in the list by simply saying counter +1. And then we draw the current waypoint on top of the line, if we've drawn the line. Well, regardless of whether we've drawn the line. So now that we've got the basic model for skipping from one waypoint to another, how might we use the same basic principle to calculate the total length of our route? What's the algorithm? Pause the movie and have a think. Well, imagine that we're performing the same process as before, but this time, instead of drawing a line between the two waypoints, we calculate its length and add it to some running total. So we set some length variable to 0, and then we skip again along the waypoints just as before, but this time we add to length the distance between the current waypoint and the next point. So we start here and we say, okay, what's the length of this leg here? It's that distance. Okay, what's the length of this leg here? That distance. And at every step we add each leg until we get to the last but one waypoint, in which point then we print out the length of the route. And how did we calculate the difference between two waypoints? Well, we already did this manually in an earlier workshop when we calculated the distance between the mouse pointer and the center of the screen. But as we mentioned at the time, processing has a method to do the job for us, dist. So if we give the dist method 2 points, x1 and x2, x1, y1, x2, y2, dist will tell us the Cartesian distance between them. So here's our length calculation method, which we've added to the route class, which is now in waypoints 5. So it has pretty much the same structure as the route drawing method, as we're essentially doing the same thing. We're skipping across the waypoints, at each point doing something with each leg. Only this time we're adding distances instead of drawing lines. So we declare and initialize a temporary distance variable, which is a float because the distance will generally not be a whole number. And then again, as before, we skip over the waypoints, missing out the last one, but this time we basically get two temporary waypoints. We extract them from the array, and then we basically say the distance between these two waypoints is the dist between the current waypoint x, y, and the next waypoint x, y. So we've basically created these two temporary waypoint objects. Just to make things clear, we extract them from the array, and then we basically say, okay, the distance between these two waypoints, or the hop distance, is the distance between the current waypoint, this waypoint x, y, and the next waypoint x, y. And then we simply add to distance, the working distance. Distance is distance plus this hop distance. And then we simply return the total distance of the route to the calling method. And we'll use this again shortly.